Hello everyone, welcome to Learn Overflow. In this video, we'll understand how we can solve today's LeetCode problem, that is a valid binary search tree. This is a medium level problem, and we'll understand exactly how we should go ahead solving a question like this, how we should think of finding a solution on this kind of question. Also, we'll understand the in-depth of this binary search tree and what can be the loopholes in this question that may arise. We'll understand all of those in this video as well. Towards the end, we'll write a code that will solve this question as well. So that's more or less the sum. So before moving on, make sure to subscribe to this channel for regular code videos like this. Also, make sure to take a look at the description. Here we'll find numerous other details about this question as well. So that should be helpful for you. So let's start with this today's question. The question says validate binary search tree. So this validate binary search tree, the question says like given the root of a binary tree. So we are not given any array or something like that. Like the in the example, it looks like an array, but this is not given. We are given a binary tree. Okay, and we need to determine if it is a valid binary search tree or not. So when it says binary search tree, what it exactly means? It exactly means that the left subtree of the node contains only node that are like less than the node's key value, and the right subtree contains node with the keys greater than the node's key value. We'll understand this in example. And also the third point to validate this is like we should keep a look that the both left and right subtree are also binary search tree. Whenever you see a condition like this, that uh, something is getting repeated, okay, like the both left and the right subtree are also binary search tree, that means you need to again check for these conditions. Okay, more or less this hints about recursive kind of solution. Okay, I should do this recursively on both left and right subtree as well. So that's you can take a note of it. So let's understand what exactly we mean by this. We mean, let me just draw a binary search tree and explain to you. So here we have a binary search tree in front of us. Let's understand exactly how this points they say over here, how this points apply to this. Okay, so it's the first is says the left subtree of the node contains keys that are less than the node's key value. What's the node's key value? Node's initial root node's key value is 8. So the left subtree will contain values that are less than 8, and the right subtree will contain values that are greater than 8. So that's the 2 points being given to us. Okay, and further it says the both left and right subtree must be minus st. So again we need to repeat those two conditions for the left and right subtree. Let's see. uh, Here on the left of 8 there is 3. Fine, that's the root of the left subtree. So this left subtree is left, that is 1 is less than 3, so that validates. And 3 on the right of 3 there are 6, 4 and 7. With all this is greater than 3, but look carefully, there is a small thing you need to note over here is like on the right of 3 there's 6, 4 and 7. All this is less than 8 as well. Fine, so that's important over here. All these are less than 8 and greater than 3, so those are on the right. Now on 3's right there's 6. Fine, we find a root being 6. Now on left of 6 we find 4. Okay, on left of 6 we find 4, but look carefully, that is greater than 3 as well. So the all the values that is on the right of a node are greater than the node's key value. Fine, so 4 is on the left of 6, but that is greater than 3 as well. Fine, and there's 7 on the right of 6, that is less than 8 as well. Fine, because that comes in the left of 8, right? So that's why 7 is less than, like whatever value is there is less than 8 as well. Fine, if we go ahead adding more values over here, that should follow the same rules for us. Fine, by any chance if you want to add a 5 after 5 in this, so how will you go ahead with that? 5 will be less than 8, that is will come on the left subtree. Next it will find 1, like find 3. 3 is like less than 5, so we should go on the right. Next it will find 6, so it will find that 6 is greater than 5, so it's come to its left. Then we'll find 4. 4 will be less than 5, so 5 will come to its right. So if in case we want to add another value, so that's the idea in this. Okay, and the similar thing goes on the right sub tree. On 8's right, all the values are there that are greater than uh that are greater than 8. So let's see, there's 10. 10 is obviously greater than 8. On 10's left, there's a null, so no values are there. On 10's right, we find 14. 14 is obviously greater than 8, and on 14's left we find 13. 13 is less than 14, but look, greater than 10 as well. So that's the idea over here. Fine. So that's an important idea over here. Now, keeping a note on this, we should go ahead and like write our solution. We should always keep a note of the mean and the max, whatever the minimum value we have, whatever the maximum value we have. So once we keeping a like track of that, we can easily go and check for that. But we need to validate. So the main idea is to validate whether the current root value lies within our min or max, or like is greater than max or is less than min, or if this condition becomes valid that the current root value is greater than max or less than min, then it's a false. It's not a binary search tree. If it's not, we will keep on checking the other values and we'll ultimately find it out. So that's the whole idea. To find it out, we'll use another function to keep a track of the mean and max, and that's how we should find a solution, or keep a check, or directly check whether this is a binary search tree or not. So we'll directly go ahead and write a code for this and ultimately find out how it works. So let's do that. Yes, so here you can see it's again at 0 millisecond solution and it's faster 100%. So let's understand what exactly we did in our solution. We first of all, in our given function, this function was given to us is valid BST with the root node, and here we just call another overloaded function that's the is valid BST with the root and min and max, two different values. Okay, so what is initially min and max? Min and max are the long min value and the long max value. Okay, so those are the two values we have over here. Now, what further we did, we went ahead with like finding values like we just ran this recursive loop. That's this function. This is a helper function for us, and this is going ahead with a recursive function. How is going ahead? First of all, it's checking if the root is null. If our current root is null, then it's true. How is it? So if the root itself is null, so is there any point to check whether it's less than mean or greater than max, anything of that sort? So that we know that it doesn't have a value, so it's true. Go ahead, return with it's true. We'll look for on the other side. Fine. It's more like you are checking on the left of this three, on this particular tree. You are checking for the left and right. Okay, you are checking for the left and right. So if the that is the case, so uh, that kind of case we are checking over here. Fine. So that's not a possible case as we know. So we simply found that this root is none is returned true. Now the next the check we are checking is like if root dot value, the current value of our current root is greater than our max, greater than or equal to our max value. Okay, this cannot be equal to our max value as well. So that means like uh, say on the left, say this one. So this value cannot be equal to two itself. Okay, it should be less than two. Nowhere it says like it says less than equal to the roots key. Okay, so it should be perfectly less than key value. So we need to check for greater than equal to max. That is the other condition, that the other side, the condition that cannot be possible. So we are returning false based on that. So we just check this root value is greater than equal to max. That means somehow it's not on the, it shouldn't be on the left. So we find or the root value is less than equal to mean, that is this 3. If it becomes less than mean, the mean over here is 2 for us. Okay, if it goes below that, so we should return a false for us. Okay, and if this condition is not getting like triggered, then we'll simply go ahead for checking is left and right of the current node. Okay, I will do that. We will return an AND operation of two function calls. One function call is going for the left, the other function call is going for the right. So we are calling this is valid VST, this particular function, with a root dot left, and the next time we are calling root dot right. So what in the root dot left, what we are doing? A mean till our root val. That is our endless mean. The mean we have on the left hand side is like a long mean value to our current root value. Okay, so that's the call we are doing, and on the other side we are getting a dot right, that the right value till our like we are doing a root dot val, that is current root value till the max. Okay, so we are breaking it into two parts. Okay, now in that condition we'll run this loop infinitely to ultimately find out what's the exact of answer of this, like how, like we'll exactly find out, like if anyone returns a false, that returns a false, and ultimately we'll find if it's false or true. So if it's true, it will return true in any ways. Okay, so that's the whole idea. So that's how we are finding a solution to this kind of question, and you found out that this is like a zero means zero, that's the fastest solution you can have over here. So that's more or less about this video, guys. So I hope I can make you understand how you can solve a question like this. Also comment down if you want any particular question to be solved as well. For regularly you will find videos on LeetCode questions over here. So make sure to subscribe to this channel for regular LeetCode videos like this. I'll be happy to help you out. Any of your doubts you will post in the comments. So make sure to do that as well. Also, if you find it helpful, so you can like this video. That won't take much of your time. So thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.